So today this is about building polynomials by giving you clues. We would not have given you this answer, but what if we had told you that it has a root of x? Well, see how we factor this, and all of a sudden you can see that it has a root of x. And then, see how there's a root of x? Because that x there, that root, I should say, I'm saying root of x. It actually means x factors out of it, but the root is actually 0. Do you see that the green one goes through 0? Because there's an x in front, it goes through 0. Well, what if we could factor it the rest of the way? Can we? Can we? Take an x out, and then can this part factor? Well, 5 times 1 is the only way to make a 5. So it'd have to be an x, and I always say to do the positives and negatives next, you know, the signs. Would you agree that since there is a negative, there has to be a negative sign, at least one? Okay, so then there has to be a negative, and then the other one has to be positive, so you can know that. Now, I can't know which one of them is plus and which one of them is minus, but one's a plus and one's a minus. And the third thing in factoring is to figure out the last two numbers, which is a 5 and a 1. So, is it 1 and 5? Will a 5 and a 1 actually work out? No. But a lot of people said on the last test, so therefore it's not real. Just because I can't factor it doesn't mean it's not real. They're real. Look at them. They touch here and here. They're just decimals. They just won't factor nicely. So I've told you before, if you can factor it, you should, and we did. We got the x out, but we couldn't factor it any further. All right. So here's one where I'm going to give you the clues a little more that are a little nicer, okay? And I want you to draw me a graph for this scenario. It's got roots at 0 and 5. It's going down on the right. What's the equation? Now, I said it's going down on the right. Could I have said that in a more obscure way? Yeah.
Like the end behavior?
The end behavior. Right. I could have said the limit of the function as x approaches infinity is negative infinity. Just to clarify, this would mean the same exact thing. That means going down on the right. And if you understand limits, you're like, so you're saying when x goes way to the right, when I move way to the right on the function, it goes way down. And that's the same as going down on the right. What's another way to obscurely say that my function goes down on the right? Use the word lead. Mr. T. Yes, it has a negative lead coefficient. Because that's what it means. If your equation starts with a negative something, then it's going down on the right. So how many of you knew that it was negative? And then I will accept x plus 0 because that would give you this. But what would be simpler than saying x plus 0? X. Yeah, just x would be fine. And then x minus 5. Do you agree that this equation would have roots at 0 and 5 and goes down on the right? Okay. What would it do on the left? Up or down? What's the lead term of this thing? Y equals, remember how we find the beginning, then we don't care about the middle, and then we care about the end? The lead term would be negative x squared. True or false? True. So it's down on the right, and that says same on the left because it's even. We want it to be the same. All right, and then the y-intercept is where x is 0, so I can stick in a 0 here and a 0 here, and I would have, this is important, is it going to be negative 5 or not? I mean, I know this part's negative 5, but then this part's 0. What's 0 times negative 5? 0. So my y-intercept is 0. That means it goes through 0, which is what we knew in the first place, right? But it's easy to get your y-intercept and your x-intercept confused. You like think that they're different. If you've got a spot at 0, 0, it's the x-intercept and it's the y-intercept. Okay. All right, here's another obscure one. Let's see if you get the equation for it. My polynomial has a double root at 4. At a 0 of 6. What the heck is that? If I said a 0 is 6, doesn't that mean that the x-intercept is 6? If a 0 is 6, one of the zeros is 6, that means one of the x-intercepts is 6, right? Okay. At a 0 of 6, it passes through. And last but not least, limit of the function as x approaches negative infinity, I hope you know which end that is negative infinity. And also the right end limit is the limit of the function as x approaches regular infinity is regular infinity, positive infinity. What's the equation for that one? Now, this one might mess with your head a little bit. When you're done writing your equation, just go through it step by step and say, does mine have a double root at 4? Does mine have a 0 of 6? And is my function passing through there? And does mine have this weird looking limit here, which really is telling me that it's up or down on the left or the right, and hopefully you know what that means. And does mine satisfy this limit here? And if it does, then there's actually more than one way to write this answer. But as long as yours satisfies all of those little pieces, it's right. This is called building functions, and that's what we're doing today. Marcus, not your normal spot. What's going on? I know somebody else. Oh, there's somebody finishing a test there. Okay, that's fine. All right, so back to Kay. Can you tell me what you think the answer is?
I haven't completed a lot of.
Okay, tell me anything you know about this answer.
Maybe x minus 4 quantity squared.
X minus 4 quantity squared, I agree 100%. Because that gives me a double root at 4. All right, Anjali, tell me something else you know about this answer.
It's also multiplied by x minus 6.
All right, so I'm going to put a x minus 6 like this. Is that right? Good. By the way, what is the multiplicity of that? Ask yourself, do you know the multiplicity of this? 1. Multiplicity is just a little name for the little power at the top. What's the multiplicity of this one? 2. That's just, the multiplicity is just basically another name for the power of it. Okay. And now, if I work out and figure out the lead term of this thing, y equals something to the something. I don't care about the middle, and then maybe be smart to figure out the y-intercept. Everybody do that for your equation. For your equation, the equation you wrote. Does yours have a lead of x to the 3rd, like mine does? And is that even right? And does yours have a, well, your y-intercept probably is the same as mine, which is 16 times negative 6 is negative big. I am okay with that. It's a big negative number. This one's positive 16, but then I got to times by negative 6. And sometimes your answers are really, really big or really, really small. And we really don't care that much. We just, if we're going to sketch it, we got to make sure that my actual answer here, which goes through 4 and goes through 6 and bounces at 4. And what does this mean? The left end goes down. That's what that means. and the right end goes up. And it's got to bounce at the 4. So it should be passing through here, bouncing off of there, and then going down. Would it eventually have a big negative y-intercept? Yeah, look, it's headed that way. Looks like it's going to have a y-intercept that's really low. I think mine is right, which was y equaled x minus 4, quantity squared, x minus 6. Now, would there be another possible answer? Yes. There's more than one way to do this. But, does anybody else have one that they think is right? It's different than mine? Okay. All right. One more where I give you one and you build it. This one is degree 5. This function is degree 5. Next, it's got a double root at the origin. It's got a double root at the origin. The lim of f of x as x approaches infinity is infinity. One last thing. There's a root at negative 7. There is more than one possible answer for this problem. Make me an equation that would have all those things. It's degree 5. I know some of you think it's not possible, server. It's possible. When we're done with yours, ask yourself, does mine have a degree of 5? Does mine have a double root at the origin? Does mine have that right limit? Does mine have a root at negative 7? If you've got all of those things, then yours is right. And pause for a second while you compare with the kid next to you. Okay, let's see how you did. Again, it's totally different for each kid because there's a lot of ways to do it. Sam, I'd love to hear yours.
Y equals x squared multiplied by the quantity x plus 7 cubed.
All right. Now, you might have done yours different than him, but let's just see if his works. Does his have a degree of 5? Yeah, if I multiply his all the way out, my lead term would be x to the second is going to get times by the x to the third and make x to the fifth. That's good. Okay. Does his have a double root at the origin? That's 0, so that's the origin. If x is 0, then it's the origin. Okay, so 0 squared means a double root, so yeah, he's got a double root at the origin. Does his go up on the right? Because that's a really fancy way of saying up on the right. And his does because it's positive in front. And his has a root at negative 7. Because if you put a negative 7 right there, it makes it equal 0. Now that makes you think that his is the only way you could do it. False. Who's got another way that checks all the boxes? Mira. I'm ready.
What I did was x squared
X squared.
times x plus 7.
X plus 7. And that's got a root at negative 7 and a degree of 3. Or no, wait. Okay, so keep going.
Then multiplied by x plus 3
She just made up a root.
and x minus 3.
She's made up another root. Well, it never said that it didn't have roots at negative 3 and 3, so she can do that. If it had said the only roots are at here and here, then Sam was right. But it didn't say that, so I like it. Yours has a degree of 1, 2, 3, 4, 5. Degree 5, it's positive in the front, which is this part. It has a root at negative 7, which is that part. It's got a double root at the origins. This is the squared part. And its degree is totaling 5. Perfect. Okay, my point, there can be more than one way to answer these questions. All right, move on to this page. Now, this one is being really obscure about the question. What they're trying to ask you to do is a long division of polynomials. Okay? Okay, now we're not going to ask them in that strange of a way. All right, I'm going to give you one that I want you to do. And this is a tougher one. Wait. That's a polynomial long division question. And the question is if you can do it. Sean, do you remember how I said to always start these?
Start by with X.
With an x. Is x enough in this case? Yes, it is. X times the x squared makes x to the third, and then I'm just making sure you guys know how to start. Okay, you either know how to do this at this point or you don't, so let's see. And there's also the you made a dumb mistake thing. That happens all the time, but I do it too. X times 1 is x, and then I go, wait a minute, it's not matching up. Like, this will match up when I do opposite, opposite. These match up nice, but then these don't match up. Now, you can do it two different ways, but I strongly recommend you just move it over and say, I'm going to move the negative x over here. You can do that. And then that'll cancel that. And then I'm bringing this straight down, and I'm bringing that straight down. And then you'll realize pretty quickly that that and that are identical, so I just need a 1 up here. Boom, raise your hand if you had that one right. Cool. Okay, so that one had 2 imaginary roots. Know why? Watch what happens. Your final answer is supposed to be written like this. That's a real root, Mr. Server. I don't know what you're talking about. It's real. That one's not real. Know why? How could you make that side 0? You can't. Unless you put in an imaginary number. Just side note, x squared plus 1 equals 0 can be solved. It just has to use negative square root of negative 1, which is also known as what? I. So then this is absolute value of x is I, so x is plus and minus I. That's 2 imaginary roots and 1 real root. A total of 3 roots. If you graph this, do you get it only has 1 real root? If I graphed it, I'd only see you touching once, 1 x-intercept. You can't see imaginary things. We all know that because nobody's seen a unicorn or leprechauns. You can't see imaginary things. See what I'm getting at there? If I graphed this thing, it would go through negative 1 because of that. But then I don't know what else it's going to do because it's not going to have any other roots that I can see. But there's 2 imaginary ones. And the reason I know it's degree 3 is it's going to have, it's going to be going up on the right. Why? Because it's positive infra. And down on the left because it's degree 3. So how come it's only got 1 root? Because 2 imaginaries. All right, here's one more beast. Let's see if we can do this long division problem. Ready? But inside the den is the dividend. I like to think of this as like a bear den. They crawl into a den and sleep during the winter. X to the 4th minus 4x to the 3rd plus 5x minus 20. And then, for the outside, what if I said 4 was a single root? What? 4 is a single root, not a double root. Is that enough of a clue to tell you what to put here? Notice I said single root, not double root. If I said double root, then it would have been like involving an x squared. 4 is a single root meant x minus 4. Now this one's gonna get weird in the middle, be careful. I think most of you knew to start with x to the third, and that's gonna all work out peachy at the beginning. And then minus 4x to the third. Opposite, opposite, they all cancel, and then what happens when they all cancel? Just bring one thing down? Matilda, do you know what to do next?
Even above that.
Yes, 5x minus 20. And then I can just put a 5 here. True or false? Okay, 5 times x, 5x. 5 times negative 4, negative 20. Opposite, opposite. Sweet, it worked. All right. That wasn't that hard, Mr. Server. Well, the weird part was there was no x squared in here. All right. Like, there's normally an x squared and there's normally a regular x, and it's because we did this weird, like, double thing canceled that worked out okay. All right. Let's try one more like this. 4x to the third plus 3x squared plus, minus 8x minus 6. Ooh, very good. But the question is, can you long divide that thing by x squared plus 1? Four x is a good start. Most of you probably knew that. Did you catch that something gets weird right here? Because these cancel, but the other two can't even match up because one's x squareds and one's x's. So you move it over. Remember, it would have been plus 4x, but then you go and make everything opposite, so it's minus 4x. Now I bring this down and I have 3x squared, and when I bring those two down, I have negative 12x. Now that's a good sign because this is factorable. They both have a 3 in them, so it's a good sign. I'm not saying it's going to work, but it's a good sign. So now I'm going to put a 3 on the top. Because 3 times the x squared makes 3x squared. I know I'm doing it right because of that. And now I'm going to do the 3 times the 1, and I get 3. Dang it, that goes way over here. Now I'm going to do the opposite thing. Opposite, opposite. And then this cancels, and I have negative 12x still. And then I bring this negative 6, and the negative 3 makes negative 9, and that's not a good sign. Didn't factor. Well, it is factorable, but the 12 won't factor off cleanly, so I don't think it's going to work. So I'm going to put a what at the top? What could I put at the top that would make that work? Is there anything I could put up there that would make that work? And get that to come out with a negative 12x? Nope. So, moral of the story, that one doesn't factor by this. So the question is, in these problems, is this a factor? If so, you get a 0 remainder and you get the answer. But what if it isn't a factor? Then you say it's not a factor. So x squared plus 1 isn't a factor of this.
Mr. Chairman,
Olivia.
what if you, after the plus 3 at the top, what if you put like a x to the negative 1?
X to the negative 1. Interesting. Okay.
Or negative
Then all of a sudden you don't have a polynomial anymore. I know you didn't know that that's not allowed, but x to the negative 1 means like 1 over x, and that's not going to be in a polynomial anymore. And therefore, it's out. But I love that idea. Yes?
So in the homework problems, what they did was they just multiplied the 4x plus 3, in this example 4x plus 3 times x squared plus 1, and then at the end they just did minus 12x minus 3.
I get what you're saying. So the way that they would want you to finish right now is this, because remember when we had, like, here's a simpler one, 7 goes into 10, 1 time, 3 remainder, that this is really 7 times 1, which is this, times this, plus 3, right? You guys remember that? This and this and this are the 3 parts of the answer. It's this times that plus that. So you're right. It's this times this plus that, and that part's the remainder. And that's that would be really complicated. I don't think we would do that to you, but it is true that that's what you would want to say. Maybe if it's an R4 or something. That times that plus that gives you that. Okay, I think that's enough practice on long division of polynomials. Next, the polynomial application problems. Do you remember this problem? Well, let's see if you can do another one that's like it. A quick 2-second reminder. It came down to volume is length times width times height, and the volume had to be the length, which in this case was 12 minus something, because it's not going to be 12 anymore when you cut a corner out. And then it was the width, which was 10 minus something, and then it was the height. Okay, good enough reminder. New problem. The boss says, we got a ton of this cardboard, like literally a ton of this cardboard. And so we're going to use it, even though it's not ideal boxes for our product, we can make it work, because we don't want to waste this literally 1 ton of cardboard. We'd have to pay to get rid of it. So we're going to take this 14-inch long by 4-inch long cardboard, and we're going to do that same little dealy bob where we cut a corner out, and he says, hey, can you tell me the most volume we can get in this? Let's say that you guys sell, I found this cool sand which has got a little bit of like clay mixed into it, so that it's like sand you would play with on a beach, except even better, because then when you make the little castle or whatever, it sticks together so perfectly because there's a little bit of sand in, or a little bit of clay in with the sand. How many of you guys have seen this before? Any of you? Okay, it's a real thing. Okay, so it's like clay, or it's like sand, except it's like beach sand, like dreamy beach sand, where you can squish it and fold it and mold it any way you want. Okay, so that's what you guys sell. And you have these boxes you want to use up, because you got literally a ton of this sitting in the warehouse. So you're going to make some boxes. So these dimensions, again, are x here and x here and x. And I don't want to keep drawing x's, but I think you get the idea. They're all x on the little corners. And he says, I want you to take your calculator. You're smart. Would you please figure out for me the most volume I can get in this box? We can start with the volume formula. Charlie, what is the volume formula? That is half of the volume formula. Just the beginning of it is all I'm saying. Yes, you got to have that. And please don't forget that, everybody, because then when they tell you the volume, you can stick it in here. Because, like, what if he said, we want to be able to put in 10 cubic inches or something like that? You'd stick it in the V part. So we want the whole formula, not just the after the equals part. Okay, now would you please write an equation for this? Use your calculator, because calculators are allowed on this next test. Imagine at least that they are. And you're allowed to graph this thing once you've written it. And then I also need to know the domain of this thing. And that's very important, because your graph's going to look really weird, but you're only allowed to go between x is this and x is that. And in that range, there will be a highest volume that you can have. So figure out your domain, figure out your equation for this thing, and then use your calculator and try to figure out, I don't know what it's going to look like. You figure out what it's going to look like. And then find the highest that the volume can be. Remember, the volume will be this way, and your x dimension will be that way. All right, that's enough hints. I'm pausing for a second, and I want people to work in groups so that you can verify with each other you're not going way off the path. And some people have no idea what's going on, so I'm going to get you a little further by asking one of the groups that is on track, what's that equation then? If you guys get the equation, would you please raise your hand? Okay, give me an equation. You're right. I guarantee you're right. It's just like we did before. Go ahead, Kay.
X times 14 minus X.
And I'm going to put the X at the end, and then I'm going to go like that instead of putting it in front. Why is there an X there? Because that's the height. When you fold this box up, the X is the height. Okay, and then what was the length?
Length 14 minus X.
Oh, so close. 14 minus X. So look at this 14 here, and yeah, we're going to have to subtract off this X. Ah, there it is. 14 minus 2 X's. Because look, you'll have to subtract off an X on both ends. It won't be 14 anymore. It'll be 14 minus 2 X's. And then how about the other direction? Campbell. If this was 14 minus 2X, what's this direction going to be?
4 minus 2x.
Yes. And then the last dimension is just X, because however big you call X, whatever big that is, that's the height. You guys get how I got that? Now you could graph that with a calculator. And it would look kind of like this. But wait, I said define the domain first. Talk about how big X could be. Could X truly be anything you want? No, you could cut an X that is way too big. You could have cut an X that was like so big that the side couldn't even exist. Okay, so figure out how big X can be. It must be between this and this. Talk to your partner, figure that out, and then graph it. It won't look like this, but it'll look kind of like that. Yes, sir. All right, y equals. Do you know where the graph, like the y equals button is? Okay, good. Now, do you have a whole bunch of y equals? All right. Do you know how to type this in? Just type it exactly the way you see it, but the X button is the one that is, how do I describe the X button? It's up by the alpha key. It's right next to the alpha key.
So it'd be like, okay, so wait, if our domain is,
All right. Yours is in the original configuration.
that would be this one, right? I just put it in just like that. Then that's it. How do you find convergence? So we have, there's
There is a way to do it. I want to let kids struggle with that in the first 3 minutes, try to figure out. If you haven't already got it typed in, if you have no clue where to start, here, let me record this. So I have a startling number of people who don't know how to type this in. First you hit the y equals button. Then you put in parentheses 14 minus 2, and if you don't know where the X key is, to type in an X on your y equals screen, it's right by the alpha key. There's a button that's got an X and a T and a theta and a something, but if you hit that button, you'll get an X right here. If you can't find that button, please let me know, and I'll walk over there and help you. 4 minus 2, and again, that same button that's by the alpha key. And then one more time, that X. And then if you graph that, you're going to get a curve that goes kind of like that. All right, get that up on your calculator, and then we'll talk more. If you're struggling with tech, please raise your hand and I'll come help. Okay, so some people see this right away, which is awesome. And some people's graph looks like this. And they can't see the top. It's cut off. You know what I mean? Like they can't see it well enough. Do you get that that's a moment where if your calculator's doing that, you got to see that top part of the graph. You have to zoom, what, in or out? You want to zoom out. If you don't know how to do that, there's a button called zoom. And then when you hit the zoom button, you'll want to go to zoom out, and then you have to hit enter to actually zoom out. All right. Pausing for a second. Hopefully everybody can get it so you can see the top here. I was not able to check with all the groups, but I think almost all the groups have got theirs so they can see the top of this little peak. Did you figure out the domain was that x had to be between 0 and 2? Why? Because in our box, this side is 4. How could you cut out corners that are any bigger than 2? So between 0 and 2 is all that matters. So between here is 0 and here is 2, we want to find this high spot. Now, trace is not a bad way to go. It brings up that little spider, you know, and then you can kind of move the spider around with the left and right arrows. That works, and you get to the top, and you figure out that, which is really the x of it, which I would guess would be like 1 point something, or maybe it's 1, but who got an answer for that? It better be between 0 and 2, otherwise you did it wrong. Let's go with K, since I picked on you before at the very beginning.
As a coordinate.
Okay, tell me the x and the y, and then we'll just interpret what that means.
0.96,
0.96, really close to 1. Keep going.
24.
That means at little less than 1 second, the ball was at 24 feet. What? 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 No, obviously not. At 0.96 watts. Chickens. At almost a full chicken, you get 24 calories. No, that's not it, I guess. Asher, what is it? 0.96 watts. Cows?
It's
Inches. 0.96 inches. So that's about 1 inch. Corners on our box. We get 24 chickens?
No, we get 24.
Our formula was V equals
sorry.
L times W times H.
I don't know.
It's okay. Too much pressure.
I'm blanking.
The volume. The volume is 24.
I wasn't sure if I was
So at a 1 inch corner, you'd have a volume of 24. All right. I know that was complicated. Don't worry. We're not going to push you that hard on this test, but you're in honors, so I pushed you a little hard today. Could you write the equation for that, though? I hope that part was pretty easy. And the next unit we do, that's where we go to the next level and say, we want the volume to be 24. And then you have to solve it, that kind of thing. So at least for now, you know how to do more than you'd have to do on your test. You'd have to be able to write me an equation, though. So, building polynomials from descriptions, if I give you a couple zeros, plus and minus this, and plus and minus that, then it's like x plus 2, and x minus 2, and x plus 1, and x minus 1. There, I just made all the roots, but I better check. It says, oh, the leading term is 117, x to the fourth. Then you just got to throw in a 117 somewhere. Maybe you could put it at the very front. That'd be okay. Or you could put it on one of the x's. Do you get how I made that equation? You're just building equations like that. All right, so I'm going to recommend that you do all of them on the front page. The green page would be a very reasonable sized assignment. And tomorrow is the official review, and then Wednesday's the test. Is there anybody that knows, because you're going to go over the river and through the woods to grandmother's house for Thanksgiving, that you're not going to be here on Wednesday? All right, then you and I should talk about what you want to do about the test, because you're obviously going to miss it. So you can do it on Monday after, or you can do it, try to do it beforehand somehow, but that's going to be tough. All right, that's all I got for you for today. Great practice. This is a good stretch problem, but I'm going to call it a stretch. Like, we wouldn't be able to test you on something that hard. That could, nope. Okay.